Welcome back. Good evening, students. Today we are starting with new topic, that is indices and cube root. We have studied in our earlier standard about indices and laws of indices. So if you have a number, say 2 into 2 into 2, suppose, then it can be also written as 2 to the power of 3, right? And this can also be known as the index form of the number. So where this 2 is known as the base and the 3 is the index. So 2 into 2 into 2 can be written as 2 to the power of 3, which is known as index form of the number. Now we know some laws of the indices, like in our standard previous classes we have studied about this laws, where suppose m and n are integers, then if you have a to the power of n into a to the power of n, then we can write it as a to the power of m plus n. Remember, here base should be same and the multiplication sign should be present. Then only you can represent it as a to the power of m plus n. So if base are equal or same, then their respective indices or indexes can be added, or you can add those. If you have second thing, say a to the power of m divided by a to the power of n, then this can be written as a to the power of m minus n. So division can be written as minus. Again, the base has to be same. If the base are same, equal, respective indices can be subtracted. This can be also represented as a to the power of n upon a to the power of n, and again you can write it as a to the power of m minus n. Next you have a times b whole power of m. Now here you see the base is a into b, a times b. Then you can write it as a to the power of n multiply by b to the power of m. Both the index are same but the base are not same. Then you cannot sub or add the powers because your base are not same. A to the power of 0, anything or any number raised to the power of 0 is always equals to 1, right? Next you have a to the power of n to the power of n. This can be written as a to the power of m n. Okay. Next we have a to the a by b to the power of m. So like we had done in like multiplication, similarly a to the power of m upon b to the power of n. And when you have a upon b to the power of minus m, then you have to simply reverse the division. So b to the power of a whole raised to this minus can then be written as plus. Okay, so this all indices that we saw are integers, right? Here you have indexes which were all integers, like 1, 2 or minus 3, minus 5 or whatever, minus m plus n. But when the index is a rational number, then what? Then how you will read it, or how you will interpret it? So rational number like 1 upon 2 or 1 upon 3 or 1 upon 5, or for that matter 1 upon n. Now you have learned that square of a number can be written as like 2 raised to power 2. So this is square of 2. So here you see the index is always 2. Okay, when it is a square, the index is 2 and 2 is an integer. But what about square root? So when you have a square root of a number, then in that case the index will be 1 upon 2, that is a rational number. So whenever you have a square root of a number and you have to write it in an index form, then it can be written as 1 upon 2. So for example, if you want to write a square root of 25 in index form, then it can be written as 25 raised to 1 upon 2. So this is the index form of square root of 25. You have written it like this in your previous standard, but it can be also written as 2 to the power of 25 raised to 1 upon 2. So square of a number can be a to the power 2, whereas square root of any number could be either written as square root of 2, or you can also write it as square root of 2, because there is no number, it is considered it as 2, or you can also write it as a to the power of 1 upon 2. Similarly, when you have cube and cube root, so cube means 2 to the power of 3, something to the power of 3, then this is the index form. If you have to write a cube root in index forms, then it will be say 2 to the power of 1 upon 3, or say a is any number, so cube root of a can be written as a to the power of 1 by 3. So this is very simple representation of the cube root in index form or indices form. Now let us take some examples. Suppose 4 to the power of 3, which can be written as say 64. It's give me answer. So 4 into 4 into 4, which is nothing but 64. But when you say you have to write cube root of 64, say cube root of 64, that is cube root of 64, which can be also written as 64 to the power of 3, which is nothing but 4, right? Similarly, you have like say 3 into 3 into 3 into 3 into 3, which is equals to 243. Then we can also say it as, because there are the 3 is appearing for the 5 times, so 5th power of 3, and 5th power of 3 is 243. Similarly, if you want to find the 5th root of 243, which can be also written as 243 whole raised to 1 upon 5, which of whose value would be 3. So if you want to write any number in the root, you will say it is nth root of a number of a. So a raised to 1 upon n. So if you have say 128 raised to 1 upon 7, so you can write it as seventh root of 128. You have say 900 to power 12, then you can write it as 12th root of 900, correct? So similarly, suppose you have 10 to the power of 1 upon 5 is equals to x, suppose, then you can also write it as x to the power of 5 is equals to 10. So when your root changes the side in the with respect to equals, then it will be going to the numerator. So x will become x to the power 5, and 10 will become just 1. So x to the power of 5 is equals to 10. Now in your examples, or in your textbook examples, you have given the question as like express in index form, right? So suppose you have 5th root of 13, so how you will write it index form? 13 raised to 1 upon 5. Or say 6th root of 9, then how you will write it as 9 to the power of 1 upon 6. Now suppose you have to write the number in the form of nth root of a. Suppose 81 raised to 1 upon 4, and you have to write it in nth root of a. Then you can write it as 81 fourth root of 81, correct? Or if you have say 49 raised to 1 upon 2, then you can write it as square root of 49. Similarly, if you have say 78 to the power of 1 upon 3, then you can write cube root of 78. So any number can be expressed in the form of index form, and it can be written as something to the power of something, right? Index form of the number. And you will have examples in your textbook whereby you have to write things in the index form and you have to express it in index form. So we have seen this over here, that how to express any number in the index form. So that's all for today. Practice until we meet next time.